Hello everyone and welcome to this video. So we are going to go over the cloud security, and then after that we will go to IoT security. So just to review, we went over the cloud computing elements and we found that we have development models, we have service models, and finally essential characteristics. So for the models, we have the software as a service, the platform as a service, and infrastructure as a service. And then in this figure, you can see that what is managed by the cloud service provider and what is managed by the customer. So if we are dealing with the software as a service, everything is managed by the service provider. The customer is just going to access the application itself or manage it. And then with the platform as a service, so the provider is providing everything, and then the user has to install his own application and data. And then finally, the internet or infrastructure as a service, mostly the client is doing everything, operating system, and then install applications, everything is based on that. And then in the cloud deployment models, we have the public cloud, the private cloud, the community cloud, and the hybrid cloud. And we had the comparison between them, and mainly you can find that the public cloud is the lowest cost, but at the same time, it's giving the lowest quality of service from the security point of view, from the performance point of view, reliability point of view. And then we went over the major actors, which are the cloud service consumer, the cloud service provider, cloud auditor, cloud broker, and cloud carrier. As you can see in this figure, the cloud carrier is just managing the interconnection between all of them. And then we have the cloud consumer, which can have a contract with a cloud auditor, which mainly auditing the security, privacy, and then performance. And then the cloud provider is providing the cloud service with all its models. And finally, the cloud broker is somehow someone who is intermediate between the cloud consumer and the cloud provider. But based on that, we will find that the main contributors here are the consumer and the provider, right? And between them, you will find that the cloud carrier. So this is mandatory, mandatory, mandatory. Those are optional, right? And then after that, we went over the NEST guidelines on cloud security, and the main parts we just talked about is trust, right? And then access management, software isolation, like in VPNs, and then data protection and availability and incident response, like disaster response, right? And then after that, we went to talk about security issues for cloud computing, and the main concern here is the availability of the cloud, right? So sometimes we say we need the availability to be 5 nines, which is 99.999%. So it's available mainly most of the time, right? Also, the cloud must be, or the provider of the cloud must guard the cloud from incidents like the denial of service or theft or data protection. Um, Also, we discussed the risks and countermeasures, and let's go very quick over that. So, one of the risks is the abuse of the cloud computing or insecure interfaces like APIs or malicious insiders, shared technology issues, or data loss or leakage, account or service hijacking, and finally, unknown risk profile. Then, the data protection in the cloud, mainly we have to make sure that the data must be secured while it is at rest or in transit or in use, and access data must be controlled. The second thing actually, that the data while transmitting data, it must be encrypted by the cloud service provider. And also we must ensure access control. So legitimate users only can access data. And also, if you are the client, you have to make sure that you are encrypting your data when saving it in the cloud, right? Because at some point you may not trust the cloud provider, so you are making sure that your data is encrypted in the cloud. So if the provider try to look over your data, they will not be or they will not see any useful information. Okay. So until now, we saw that the cloud service provider can provide infrastructure as a service, platform as a service, software as a service. But what about the security? So in all cases, the client must take care of the security. This is why actually another service arose, which is called security as a service. So in security as a service, you will find that the cloud service provider can provide security features. So for example, they can provide network security, they can provide data loss protection, they can provide encryption, so encrypting data in the cloud or while communicating. Also, let's say email security. They can provide email security from, for example, phishing, intrusion management. So all of these are services. So for example, your company will have somehow compromisation between do we have to have a department for security and hire engineers for security, or just buy the service, which is security as a service from the cloud, and they will take care of everything, and I will just want just one engineer to interact with the cloud and work with them on the security, and that's it. So it's somehow you have to take the decision of taking this service from the cloud or provide this service from your enterprise. So the last thing I want to talk about in the cloud is the OpenStack, and this is an open source software that is aiming to manage the clouds, or let's say the operating system itself. So we can name it as an open source cloud operating system, and it's mainly creating and managing huge group of virtual private servers to be used in the cloud, and it can be used for private networks or private clouds or public clouds, and at the same time it can be implemented on let's say 2 or 3 servers or 1,000 servers. So somehow it can be scalable. It's not dependent on the size. So this is actually mainly used in most clouds now, which is called OpenStack. Okay, so this is what everything we want to revise from the cloud. And now let's see the Internet of Things and how actually Internet of Things is interacting with the cloud. Because once we have the Internet of Things, which are devices, right, we need to store the data, for example, or process the data. So where we are going to do that, we have to do it in the cloud. So somehow we see interaction between the cloud and the IoT. So first of all, what is the definition of IoT or Internet of Things? So if you look at all devices that are not managed by human directly. So for example, let's say your smart devices are somehow managed by you, right? But there are sensors in your device, a lot of sensors, and these sensors are taking some data or sensing some data and then giving it to a certain application, which this application is using data to get some useful results or actions, right? Also appliances at home. So for example, when we hear about the smart home and devices there, and let's say you can control them using Alexa or Google Assistant. So these are also under what we call Internet of Things. Tiny sensors, let's say in agriculture, they are using sensor and collecting some data related to humidity, and just to take the decision when to irrigate the farm or whatever they want to do exactly. Another example, let's say vehicular to vehicular communication. So now the research is going like how we can make the cars controlled by the network, and you are just directing the car. But if there is an emergency decision, the car will take it. So for example, there is a proposal to connect all the cars that are near to each other. So for example, if you are going to an intersection, excuse me, if you are going to an intersection and there is another car coming from the other intersection very, very fast, actually the two cars will communicate with each other in milliseconds, and both of them will take decision to enable emergency brake just to prevent accident. So again, this can go under the Internet of Things devices. So mainly we are having a lot of embedded devices everywhere, which can be named as Internet of Things. So how the Internet of Things evolved? So first of all, we started with information technology. We have PCs, servers, routers, firewalls, and all of these stuff. And mainly they are managed by an IT personnel, right? And then from here, you will find that most of these are connected wired, right? And then going after that to operational technology, which mainly taking the devices into the factory, installing it there, connecting it wired, and somehow taking some decisions based on software, let's say PLC or SCADA, and mainly there is an IT personnel, or in this case, OT personnel, which is again controlling all of that, right? And then going after that to the personal technology, and everyone now is having smartphones, tablets, and other IT devices, right? And most of them are actually now connected wirelessly. So after that, going to the sensors, actuators technology, you will find that we are having a certain device which is doing sometimes single purpose. So for example, finding the humidity or taking measures for humidity and so on. So you'll find that devices are very tiny devices doing certain application or certain purpose, and that's it, and collecting data. So from here, actually, we went to wireless sensor networks, if you heard about that, and the evolution of wireless sensor networks is actually the Internet of Things. So if we look at a single IoT device, you'll find that it's mainly will have a sensor or more, actuator, which is taking some actions, and the microcontroller, which mainly is the brain of the IoT device, and then an RFID, which may be identifying this device and maybe used for authentication, and finally transceiver to send data and receive data, all right? So it can collect data and send it, and then receive commands to do something else, or when to collect data again. All of these are communications done by the transceiver. So let's see now the interconnection between the cloud and the IoT devices. So as we said, the IoT devices are mainly connected to the cloud, right? And this is actually how it is done. So if we started from down there, you'll find that we are starting with the smart things network, and mainly this network can be connected by Bluetooth, Wi-Fi, or wired. So even more, it can be connected by 5G networks, right? So as I said, the connected vehicles, they are connected to the 5G network. In this case, they will have connectivity everywhere. Wherever they went, they will have this connectivity. And by the way, there are cars now which are having the feature of having a SIM card, so that the car can communicate with the network. So in this case, you will find millions of devices. And again, another example is returning back to the smart home. You'll find that you will connect all your devices at home by the Wi-Fi that you already have, right? That you use to connect to the internet. So all of them will be connected there. And then after that, the next level, we will have the fog network. And mainly the fog network is somehow very similar to the cloud, but we are bringing a small portion of the cloud near to the IoT devices. Why we are doing that? Sometimes we need real-time processing, which it will be like very hard to do it with the cloud, because the cloud is far away. There's the delay with the signal going, or the data transmitted to the cloud, and then the cloud doing processing and then returning back the signal. So sometimes we need the processing more near to the IoT devices. Also the core network, and mainly in the core network, you are dealing with the communication, the routers, everything related to high speed connections or links, and also connections to external networks, right? And finally going up to the cloud, and there you are storing or maybe having some applications, some processing to the data, right? So let's go step by step and start by the first thing, which is the IoT network. And sometimes we call the IoT network as the edge. And we are calling it as the edge because at the edge we are having, you know, the last or the end of the network, which is the devices, right? So in this case, at the edge, the devices may interact with each other. So let's say each device will send data to the other device, or all of them will send it to a cluster sensor, for example, and this sensor will send data to gateway. What is the gateway? The gateway is actually taking data and connecting it to the network in order to send it to the cloud, right? And then after the edge, we will find that we have the fog, right? And as we said, the fog is mainly getting the processing near to the IoT devices. So an example, if you are working or having IoT devices in a farm in Iowa and the cloud actually in California. So in this case, we will have like one or two servers at Iowa State University, which is near to the IoT devices, right? So in this case, these servers, two or three servers, we will name them as fog, right? Because we bring part of the cloud near to the IoT device or near to the edge, okay? So this is why sometimes they call it as edge computing, because you are bringing the computing near to the edge. And in fog, actually, you are doing a lot of things like evaluation, formatting, decoding, reduction. So if you want to reduce the amount of data before sending it to the cloud, so you are doing some processing, extract the useful information, and send only the useful information to the cloud. And also, it can do assessment and finally taking decisions. So if you look at the fog, it's somehow it's giving an opposite trend in modern networking from the cloud, right? And mainly, if you want to differentiate between them, the latency or delay is the one factor that can differentiate between them. If you have an application that the latency is very important, it's real-time application. In this case, you have to use the fog. If not, so the cloud is okay. You can just go with the cloud. And mainly the fog is doing the same thing and providing services like security, privacy, network capacity constraints, and latency requirements. And as you can see here, we have a comparison between the fog and the cloud. And the main points here, if you look, for example, for the latency, you will find that the cloud is having high latency because you have to send to most of the time the cloud is away from far away actually from the devices or the edge of the network, right? Also the access, the fog can be used mainly for wireless access, but the cloud most of the time it's wired. Also support for mobility, the fog can support for mobility, but not the cloud. Availability, the cloud is available, as we said, high availability, but the fog is not available that much time. So this is why actually we tend to have redundancy for the fog. Okay, so now let's try to look at the IoT security and the elements of interest. So if we look at the IoT security, you'll find that somehow the IoT is the most complex and undeveloped area of network security. And to see this, and if you look at this figure, you will find that the main elements here, for example, starting by the center of the network, and mostly you'll find the application platforms, data storage, servers, and network and security management systems, right? And then there in the central systems, they gather information from the IoT devices, right? And then send control signals to actuators, and somehow the decision is taken there, okay? But after that, on the edge or at the edge actually of the network, you will find the IoT devices, some of which are very simple constrained devices, and others are more intelligent unconstrained devices. Which here you will find that somehow the C is constrained and U is unconstrained devices. And also you will find that some of them are shaded devices and some are not shaded. And the shaded ones are indicating that these systems are supporting at least some security features. So for example, the gateway is shaded, and here the gateway, let's say it's implementing some security functions like the TLS, if you remember the TLS SSL, and maybe IPsec, right? And also some like devices, unconstrained devices can have a little bit of security implementation, like the applications itself can have security capabilities, and the constrained devices actually are not implementing any security mechanisms. And again, most of the time when we are dealing with IoT devices, we are dealing with some devices which can be left in the field or in the farm for like let's say 6 months or maybe maximum 1 year, right? So we have some constraint relating to these devices. One of the constraints is the battery, right? So we don't want to implement a lot of features, let's say security features, and finally we'll find that it's draining the battery, and instead of having the IoT device to stay for 6 months, it will just stay for 1 month and that's it, right? Okay, and then patching vulnerabilities. So this is a big problem actually with IoT. So again, we are dealing with very small devices, right? And these devices somehow they are not having, let's say, the same capabilities of the operating systems, the regular operating system. Let's say the Linux operating system, Windows operating system. If you remember when we was talking about the patching there, it's somehow a hard situation when we are dealing with IoT devices because we are dealing with a very simple operating system. So somehow it's not easy to every while you are updating the system, and at the same time you have limited storage on most of the IoT devices. Also, if we now look at the IoT security and privacy requirements, you will find that the ITU have recommendations for security. So mainly the requirements are defined as being the functional requirements during capturing, storing, transferring, aggregating, and processing data. So you have a lot of stages for the data, and you have to make sure that you are securing data through all these stages. So the requirements here are communication security, because there are a lot of communications happening, as we saw, going from the edge until the cloud. Data management security, service provision security, integration of security policies and techniques, mutual authentication and authorization, and finally, security audit. So let's start now by the security which is provided by the gateway. So if you look at the gateway here, you'll find that somehow it has to have some requirements, right? So one of the requirements is to support identification of each access to the connected devices. So mainly implementing access control, right? Um, and then also it can support authentication with devices. So based on application requirements and device capabilities, it's required to support mutual or one-way authentication. And if you remember from the cellular networks, what's the difference between mutual authentication and one-way authentication? If you are implementing mutual authentication, in this case, you are dealing with um, uh, the network is authenticating the IoT device, and the IoT device is authenticating the network, right? But with one-way authentication, the network only is authenticating the device. And if you try to, let's say, have a fake receiver, and the IoT device will not authenticate it and will send all data to this fake receiver. Another feature also for or requirement for the gateway is to support the security of data that are stored in device and the gateway, or transferred between actually the gateway and the device. Also, the gateway must support mechanisms to provide privacy for devices and the gateway. And it has to support self-diagnosis and self-repair as well as remote maintenance. Why? Because let's say you are having 10,000 devices, right, in the field. So it's not logic to go physically to each device to do the maintenance. So you have to have some sort of remote maintenance. Also, you have to, or the gateway have to support software updates and auto configuration for the IoT devices. So these are the main features for the gateway. So after that, there is uh, Cisco tried to develop a framework for IoT devices security. So this framework will serve as useful guide to security requirements for IoT. So as you can see here in the figure, we have four objects, which are the smart objects, right? And here mainly it consists of the IoT devices, which are having sensors, actuators, and other embedded systems at the edge of the network. And mainly the most vulnerability part of an IoT network is this part, right? Because it's somehow left, excuse me, it's left in the field, right? So somehow it's also vulnerable for physical security. If you remember when we was talking about physical security, so maybe anyone can go and take the IoT device and that's it, right? Just steal it. So this is one very important thing or issue that we have to be concerned with. In addition to, you have to make sure from the authentication integrity of data generated by the IoT device, because someone can put his own device and try to send fake data, for example, right? Also, when we go up one level, you will find the fog networking or the fog network. And as we already mentioned, that the fog network is mainly collecting data from the network and doing some processing, and it has a key issue of concern is, for example, going with variety of network technologies and protocol based on the IoT device itself. So this is also can be a vulnerability. So this is why a standardization for uniform security policy or protocol has to be used for all IoT devices. And then jumping up to the core network, and mainly the core network is a level which providing data path between network center platform and IoT devices. And mainly we are not concerned with the security there in the core network because it's already secured, and somehow it's having routers and managing connection with external networks. And finally, when jumping up, you will find the last level here, which is data center. And mainly data center is having its own storage applications and everything. And when we introduced the IoT, we didn't ask for more security features added because of the IoT devices, because already data centers are having their security features, right? So these are the 4 levels. When we go to the vertical levels here, so the first one is the role-based security, and mainly this is concerned with the access control. And when we are dealing with access control, we need it in the 4 levels: smart objects, fog network, core network, and data center, right? And then the next one is the anti-tamper and detection. And mainly of all these levels may involve components that are physically outside the area of enterprise. This is why it has to be protected, mainly providing physical security, right? And then the next one is data protection and confidentiality. And I think we talked about the confidentiality and protection of data, and it has to be guaranteed in all levels, right? This is why it's having from smart objects to data centers. And the last thing is the IP protection. And mainly the IP protection is just protecting data in motion, right? For example, protecting it from eavesdropping, right? And all other threats that we know about the data which is sent over the network. This figure shows the security of IoT framework, which defines the components of a security facility for an IoT that encompasses all the levels. So, for example, here, if you look, you will have authentication, authorization, network enforced policy, and finally security analytics, right? So, if we started with the authentication, again. Somehow, if you are dealing with any human operated devices, you will just go with the human credentials, which is given username or password or token. But when you are dealing with the IoT device, sometimes you have to work with fingerprints. So for example, going with RFID. So in this case, you will identify an IoT device from its RFID or X509 certificates, which are digital certificates, or even the MAC address. You can just try to identify it from MAC address. You already have the MAC address before installing the device and then authenticating the device by its MAC address. And then after authentication, we have authorization, and we already talked about that, and we said that the best thing actually is to have mutual authorization. So in this case, the IoT device will make sure that this is the one who is requested the information from the network actually, and then the network will make sure that this IoT device is not a fake IoT device, but is related to the network. And then after that, we have network enforced policy, and mainly these policies are given. For example, let's say route and transport endpoint traffic security. So these policy must be enforced and make sure that they are there. The last thing is the security analytics, visibility and control. So in this case, the management, the central management of the IoT network must have make sure that they are connected to the IoT devices. So let's say all the devices are having a status, and this is appearing in the central management of the IoT network, and also they can control the devices. So for example, let's say the device, I will not use it for 24 hours. I can send a request for the device to sleep, which is very similar to turning off the device, right? So all the control and visibility must be secured so that no one else can control the devices, right? So the last thing actually I want to mention here again is what is called the MiniSec. It's an open source security module that is part of TinyOS operating system. And if you didn't hear about the TinyOS operating system, it's mainly an operating system for IoT devices. It's very well known, and also it's used for wireless sensor networks. Okay, and again, if you are interested about the TinyOS and its applications and everything, there is a graduate course. As I remember, it's CPRE 543, and it's mainly having hands-on and working with TinyOS operating system and configuring the system and playing with different IoT devices or wireless sensor network devices. So as we said, it's designed for small embedded systems with tight requirements on memory, processing time, real-time response, and power consumption. Because again, the IoT devices, not all of them, but most of them actually are just left in the field, right? So in this case, you have limited power. You want to have limited power consumption. Why? Because you will just put a battery. And this battery actually, if the power consumption is high, in this case, you have to change the battery every, let's say, 1 month, which is very costly, given that we have like 1,000 IoT device or 10,000 IoT devices, right? So in this case, you have to have somehow low power consumption, and this low power consumption will come from low processing, right? So you don't have to have a lot of processing done. And also, when you are dealing with the main application of TinyOS is wireless sensor networks, which, as we said, you can just implement it using or deploy it on wireless sensor networks or wireless sensors. And mainly, when we are dealing with MiniSec, it offers high level of security, and at the same time it keeps energy consumption low and use very little memory. So again, as we said, most of the IoT devices are not using security because they are not having a lot of processing to do. But at the same time, with MiniSec, it's giving some features, which is high level of security and then at the same time low power consumption and little memory usage, which is very good and suitable for the IoT device. And if you look what is MiniSec is doing actually data authentication. So enables a legitimate node to verify whether a message originated from another legitimate node or no. So in this case, we are just making sure that the nodes who are excuse me, the nodes who are going to interact with each other are authenticating each other. Confidentiality, and this is a basic requirement for any secure communication, right? So it has to be provided. Also, replay protection. So if I capture a packet from one node to the other, and then after that, I'm going to send this packet again to the node. So in this case, it provides the protection of anyone who is going to capture a packet and then replay it in any later time. Also, it provides freshness and mainly somehow make sure that they are changing some let's say put some different numbers, or as we saw in cellular networks, using frame number or something like that, just to make sure that if someone captured a packet and then trying to send it in later time, some numbers will be changed, and this will be known by the IoT device from its operating system, which is implementing the MiniSec, right? Also the low energy overhead, and this is very important, which is minimizing communication overhead by using only, let's say, symmetric encryption. So in this case, they are having the key implemented, or the key is hard coded on the IoT device, and it's just doing the symmetric encryption, which is much easier than doing the asymmetric encryption, right? Or not consuming a lot of processing. Also, resilience to lost messages. So this actually is happening a lot because you are having a wireless medium, and most of the time you can have maybe interference or anything. So it actually try to, let's say, resend the packet or keep the packet for a certain time, resending it if it failed. So just making sure that we are getting or sending the package and received by, for example, the gateway, right? So this is everything we want to have related to the IoT devices and IoT networks. If you want to read more, there is very good interaction between IoT and 5G networks. So 5G networks actually is mainly providing connectivity to billion of devices. So in this case, they will increase the connectivity, because the 5G networks will not be only for phones or smartphones, but also for IoT devices, for connecting IoT. So, for example, you are going to subscribe for your phone, and you subscribe for your car, subscribe for, let's say, IoT devices, you are leaving them in the field, and so on. So this is how the interconnection is happening in this case. Thank you very much for listening.